with a two-link planar robot. Part C asks us to express the solutions from Part B, 1, 4, and 6 as vector addition problems. So again, two-link vector, link 1 at angle theta 1, link 2 makes an angle theta 2 from that point of axis. So we remember when in trying to solve this, what we really need to worry about is that link 2 is acting at whatever theta 1 is plus theta 2. And what we're going to do now is show we can get the same solutions that we got in Part B by adding these as vectors. So remember, vector form generically is that L is Lx in the I direction plus Ly times the j vector. The other things we need to remember for this is that L1 x is going to just be L1 times cosine theta 1. L1, the y component, is going to be L1 times sine theta 1. For the second one, it's slightly more complicated in that it's that length, but the part that we're talking about, the angle that's necessary, is the sum of the two angles, theta 1 plus theta 2. And so L2x, L2y is L2 times sine. And again, it's still the two angles combined that we need to worry about. So we want to write these as vector addition. Then we want to say that what we're really saying is that L is equal to L1 plus L2. That this big vector L, I should get a third color to quit confusing this. But if I want to get all the way from here to there, then this part is Lx, and this part is Ly. And I'm trying to figure out what those values are. And I get that by adding these two together. So to add them together, I have to first know what L1 and L2 are. So L1, if we just kind of put things together above, remember, is going to be L1 of x times the I plus L1 of y times the j, and L2, similarly, is going to be L2x plus L2y in the j direction. And of course, we've got ways to figure out those by using the slightly more complicated formulas, or at least expanded formulas. Okay, so let's go back to example B, part I. We know that L1 is 11 and L2 is 7. And for that particular example, part I, that theta 1 is 0 degrees and theta 2 is 90 degrees. And so, again, we drew that out, and remember it looked something like, just showing a quick sketch, since if you want to see it with more detail, go back and look at part B. But basically it went here, and then it went straight up that. So L1 was out this way, L2 was out this way. And I want to find this part, which is just L, the combination. Okay, so L1 was equal to the complete length, 11, in the x direction, And although it's 0, I'm going to go ahead and write it in this case just to keep up. It'll help make sense of it as I'm doing vector addition. And so it was 0 in the j direction. L2 was nothing in the x direction, and all of L2, which was 7 centimeters, in the j direction. So to add those, I just add terms down the same side. So I add my I terms together. 11 plus 0 is 11. I keep wanting to write j early because I'm thinking ahead. I plus 0 plus 7 is 7j. And that is how I would write L in vector form for this one. Again, that one was easy because we didn't have to combine anything. And I guess I should say that that is L if I'm really wanting to write it in vector form. Okay, so then B part 4. L1 was still 11. L2 was 7. Theta 1 this time on part 4, we just finished doing that a second ago, so hopefully you have it right next to you and you'll be able to check this in a minute. But theta 1 is 45 and theta 2 is 30. Okay, so let's work with that. So L1 must be 11 times the cosine of 45 degrees in the x direction. So I plus 11 times the sine of 45 degrees in the j direction. L2 would be 7 times the cosine of not 30, but 45 plus 30, which will be 75 in the I direction, plus cosine of 75 in the j direction. And then that, again, that just comes from the 45 plus 30 is our angle there. So L is going to be what happens when I add those up. So it's going to be 11 cosine of 45 degrees plus 7 cosine of 75 degrees in the I direction. And it's going to be 11 sine of 45 degrees plus, whoops, this is what happens when you don't write things correctly. We're dealing with y's, those are the sine. Plus 7 times the sine of 75 degrees. This part is our j direction, or our y direction. And so L equals 11 cosine 45 plus 7 cosine 75. So it's 9.59 in the I direction plus 11 sine 45 plus 7 sine 75. Always keep up with your parentheses. 14.54 in the j direction. And hopefully we got that, and it should be the same as what we had on that portion of part B earlier, where we got that x was 9.59 and the y was 14.54. We're just expressing it now as our vector form. So there's one more to ask for, and I'm going to go ahead and squeeze it in down here. C for part 6. L1 is 11. L2 is 7. Theta 1. So for part 6, theta 1 is negative 30. And theta 2 is positive 90 degrees. And again, we sketched those earlier, and we remembered it came up something like well, in reality, it was something like this. This one came out here, and then this one came up and ended up just crossing. So this was like L1, and that was L2. But the math's going to work out for us whether we can visualize it or not. L1 is 11 cosine negative 30 degrees plus in the I direction plus 11 sine of 45 sine of negative 30 degrees in the J direction. L2 is 7 times the cosine of negative 30 plus 90 in the I direction. And this is where you should really use your paper to line up as you go, and that'll keep your I straight, keep your J straight, keep the pluses exactly in the middle. I'm getting a little sloppy here. Negative 30 plus 90 degrees in the J direction. We're going to add those to get L, which should be 11 cosine of negative 30 plus 7 cosine of 60 in the I direction plus 11 sine negative 30 plus 7 sine of 60 degrees in the J direction. And we did it last time, so we already know what the number should be, but let's hope it works out again. 11 cosine of negative 30 degrees. Make sure I get my negative in there, or I'm going to have a bad number. Plus 7 times the cosine of 60 degrees. So my x component, I get 13.03. That number sounds familiar from working part B in the I direction. And 11 sine of negative 30 plus 7 sine of 60. I get positive 0.56 in the J direction. One thing I failed to do on all these, all three of these, was to put in my units. That's a good way to get problems wrong, so I need to go back and write that each of these is in centimeters. Centimeters. But there's 3 questions of how we do vector addition. So the key point to vector addition is get the x parts, get the y components, add the x's by themselves, add the y by themselves.